In beautiful green Palo Alto, children play without worrying of kidnapping, murder, or molestation. Palo Alto is a sheltered town, a haven for people who don't want to face the real world. But underneath this beautiful exterior is a lurking predator, waiting to strike the students at Palo Alto High School. At this very moment, we are 95% confident that there are between 32,000 and 35,000 statistical predators on the internet, posing as statisticians to give false information to innocent AP Stat students searching for homework help online. Good evening, and welcome to Dateline NBC. My name is Ben Hawthorne, and we are tonight on To Catch a Parameter.
Oh yeah. Wait a minute, that's not right!
What's wrong with the world, mama? People living life.
I got one!
Let's see what she has.
I asked this one what assumptions were necessary for a one-sample Z confidence interval for a true mean. He said, we don't need no assumptions, baby. That will make it less fun. We can do statistical inference all night long without assumptions. I then asked him to do a statistical inference with me sometime. He responded by saying, oh, I'd like that. I will use a high confidence intervals level so that your margin of error will be smaller.
This man has successfully misled our fake student regression astray twice in one chat. He stated that you do not need assumptions and that a high confidence level will create a similar margin of error, both of which are clearly false. He is scheduled to arrive at Raggy's house at 8 p.m. in 3 days. Let's see how this plays out.
Our culprit is Mr. Smith. He is an 85-year-old potato farmer from Fairbanks, Alaska, with a Doctor of Musical Arts degree from Juilliard. He has driven for almost 2.5 days to get here. An 18-year-old girl posing as an underage AP Statistics student will greet him at the door and welcome him inside.
Hey!
Ready for some inference?
Oh yeah.
My lady.
Must have been a long drive.
It was.
Starting so soon? I need to get my 89.
Oh man.
Having a good time teaching these young ladies statistics?
No.
I have evidence here that says otherwise.
Ah.
To help you avoid statistical predators like Mr. Smith, we here would like to enlighten you as to the wondrous world of confidence intervals. The purpose of making a confidence interval is to estimate the true population average or proportion if you only know the data from a sample. If you ever find in a situation like our young woman over here did, please do not trust random people on the internet, for they may lead you astray.
Put your hands behind your head!
So let's now take a look at predicting true averages. Because Mr. Smith has already committed the most taboo crime of our era, we can do whatever we want to him. So now, please bring Mr. Smith over to me. First thing you need to do when creating a confidence interval, sir, is to obtain a random sample from the population. The sample must be a simple random sample. You cannot break the population into groups and then pick randomly from them. For instance, you could put the names of your population into a hat and then draw from it.
We don't need no stinking random samples.
But you see, sir, we have to use a simple random sample. Otherwise, our results can't be generalized. Think of it like that. Or when you take the easiest people to sample, they don't represent the population. For instance, the easiest deer to catch, those don't represent all the deer. They're just the weak ones.
Whoa, man.
Please do not interrupt me, sir.
Sorry.
Now the second condition that you have to fulfill when making a confidence interval is that the population has to follow something called a normal distribution. Now what this means is that when you graph the data from your sample, it has to follow a curve that looks like this line.
I am not normal. I am special. I will use special distribution.
But if you don't use the normal distribution, then you can't accurately calculate the interval.
You know, like when I was in class the other day and we were doing stats and it was very boring. This is why I don't like stats, because it's boring.
Shut up!
See, kids, that's what happens when you don't like stats. You get tased. Now that we've finished with the assumptions, which hopefully you should understand, we can begin to explain what the confidence level itself actually is.
Oh, I know! A confidence interval is what you create when you're trying to predict what the parameter may be, what the parameter of interest may be. So, say you're trying to find the mean of some population, you can find a confidence interval to predict in what range of numbers the mean of the population might be in.
Basically, the confidence interval is like a net that you use to catch the parameter, as if you were fishing.
Wow.
However, the net's not just one size. You can make it bigger or smaller in a few different ways. First, if you increase the number of people that you sample from the population, that makes the net smaller and more precise. Second, you can increase how certain you are in your results. Basically, you can increase your confidence level. That makes your net bigger. Third, you can change the size of your net by changing the spread of your data. If your data is really spread out, then your net is going to be really big to catch all the spread out data. But if your data is all clustered together in a little ball, then your net can be nice and small. Finally, we have to do a conclusion in context.
Oh, I know. There is a 95% probability that the true mean is between blank and blank.
That's exactly right. Now kids, now you know how to do a real confidence interval so you can avoid statistical predators like this young man.
Wait! That's not right! There's not a 95% chance that the mean is inside the interval or not inside the interval. It's either in the interval or it's not. Either 0 or 1. So, you are either 95% confident that the parameter is inside the interval, not that you are 95% sure that it's inside the interval. So you are a statistical